Hello everyone, welcome to our ABC Challenge 2024 tutorial webinar. And the topic of this year's challenge is activity recognition of nurse training activity using skeleton and video dataset with generative AI. And my name is V, and today I will explain for you about the tutorial and also the data of this challenge. So the main goal of this challenge is to recognize 9 activities in endotracheal suctioning by using skeleton data. And I want to remind you that all the participants in this challenge are required to use generative AIs in a creative way. And in this webinar, we will cover the explanation of endotracheal suctioning activity, and we will give a brief introduction to data processing and also the baseline based on a tutorial notebook. And finally, we will demonstrate how to make the forecast submission file. So firstly, I will explain what is endotracheal suctioning. So the endotracheal suctioning is a necessary practice in ICU. It involves the removal of pulmonary secretion from a patient with an artificial airway placed in the neck of a patient. And this procedure is very complicated, invasive, and can bring many risks for patients, such as bleeding or infections. So there is an urgent need for more qualified people who can perform endotracheal suctioning to offer a safe nursing care service. However, currently there is no quantified evaluation criteria for effective education in this area. So we found that applying activity recognition in this area is the initial stage to assess the order of the activities, and it can help us to evaluate the nurse skills. So in this procedure, there are 9 different activities. So first, the nurse need to prepare the catheter. For example, they need to stereo the suction catheter. They need to wear gloves and operate suction machine. Next, the nurse need to remove an artificial airway in the neck of the patient, and then they need to insert the catheter into the patient to remove the secretion. And after that, the artificial airway has to be refitted immediately. This activity is very important because when you remove the artificial airway from the patient, that's when the patient cannot breathe. So after you finish suctioning, you need to remember to refit the artificial airway into the patient. And the next activity is the catheter disinfection to clean the catheter and to prevent the infection. And next, the nurse will discard the used glove. And after that, the nurse need to change the patient's position from lying on the right side to lying on the back side. And the final activities is checking the breath of patient to make sure that all the secretion is already removed. And all the remaining activities are assigned as others. So in this activity, you need to recognize these 9 different activities. And next, we will take a look at our data structure. So in total, there are 44 videos, and we divided it into 32 videos for training here and 12 videos for submission here. We also noted this information in our challenge website, so you can check it later. And next, in this year, we only share the data for the challenge register So this data set will not be released into public. So if you want to use this data, please join us in this challenge. And we will share you this training data set. On the training data set, there are three different videos. There are three different folders like videos, annotation folder, and also the keyboard folder. So in the video folder, we will provide you the videos recorded the nurse performing endotracheal suctioning, but with only for training subjects. And similarly for the annotation file, this folder include the labels of the activities, but of course only for training subject. And for the keyboards folder, we will provide you the skeleton, the board skeleton information of all the subject, including training and also the submission subject ID. And next, we will go through our tutorial. So you can find our tutorial on our challenge website and click on the tutorial tab to access to the Google Colab notebook. Let's see. So now we will go through the tutorial. So firstly, because this tutorial is made in the Google Colab, so we need to connect the Google Drive to access the data. And next, we will explore and try visualizing the data. So first, we need to import the necessary library. And here we need to define the path of the data folder. And to make the process simple, here we only use one single user for training and one single user for testing. And the sampling rate of the keyboard file is 30, and we have to recognize 9 activities. So this is the function that we will read the information in the keyboard CSV file and the annotation file. And let's check the details after we loading the data. So here is the information of the keyboard file. We will have 51 columns, including X coordinate, Y coordinate, and the confidence score of 17 positions on user body, such as nose, left eye, right eye, and so on. And for the annotation file, we have 4 columns, the start time, stop time in second, and the activity name, and also the activities ID. For the activity IDs, you can also check in our APC challenge website. Example here. You can find this information in the data tab. Here in the table 1 here, I already list all the activity name corresponding to the activity ID. So you can check it later. And next we will visualize the data. So here I will visualize the left elbow information. You can also choose another position to visualize according to the dictionary below. For example, if you want to visualize the left wrist, you can replace it here. And here is the function to plot the figure. So here we can see we have 3 graphs for the X and Y coordinate and also the confidence score. We can notice that there are some interruption in the data. This interruption is caused by the detection of the YOLO V7, because the YOLO V7 cannot detect the bone skeleton in on frame, so it will generate some zero value shock segment here that interrupt our data. So this is also one challenge that we need to handle when we use this data. And now let's check the quantity of each activity type from the annotation data frame. So from this figure, we will know the number of samples for each activity type. And next, for training and prediction, firstly, we will pre-process the data. So in our pre-processing pipelines, first we will remove the confidence score and the information of knee and ankle, because we think that this information is not useful for our recognition, but it is optional and it depends on your pipeline, so you don't need to follow us. So here is the function of to remove the information of confidence and information of knee and ankle. So let's check the result after we remove this information. You can see that now we only have 26 columns, and the information of confidence and knee or ankle is already disappeared. And next in this part is we want to handle the interruption in the skeleton data. So in here we will smooth this zero value segment by interpolating. But there is also several methods that you can use to handle this problem. So please feel free and change this like what you want. So here we only smooth the zero value segments having the length smaller than 3 seconds. So you can also change this variable. For example, if you want to only smooth the segment have length smaller than 2, you can just change here into 2 seconds. So it depends on you. And now let's check the data after smoothing. So here we can see that the data now is smoother than the original. So, and next, we will segment the data from start and stop time of each activity by design window size and overlapping rate. And next, from each segment, we will extract 7 features, including mean, standard deviation, mean, max, variance, median, and sum. So this function is help us to extract these 7 features. And now here is the pipeline processing. So first we segment the keyboard data by the window size and the overlapping rate. So here I choose the window size is 2 seconds and the overlapping rate is 50%. And then we will extract the features from each segment. And similarly, we will do it similar like that for processing the test data. And now we will have 215 samples for training and 257 samples for testing. And here in this tutorial, we will use the random forest model to recognize. And here we train the model by the training data. And next, we will evaluate the performance of the model by the testing feature. And here we can see that the F1 score is 16%. As I mentioned, in this challenge, you need to apply the generative AI. So here we provide an example that we use the ChatGPT to suggest more features to improve our model. So here is an example of input prompt you can use to ask ChatGPT. For example, here we list around the problem we need to solve, the output of the labels, and also we list the current feature that we use, and we ask ChatGPT what other feature we can use to improve the model. And here is the output from the ChatGPT. So here ChatGPT suggests us to use to calculate also velocity or to use velocity or angular features, and so on. So many features we can extract from the bone skeleton. So here, so besides from the original bone skeleton, we also calculate the joint angles velocity before we extract 7 features. And we will calculate the 6 angles. And here, in the tutorial, we will calculate the 6 angle A, B, C, D, E, and F. And we also calculate the velocity. The velocity here is the difference between the position of X and Y coordinate of the consecutive frames. And this is the pipeline. We will calculate the joint angles from the keyboard and calculate the velocity, and then segment the keyboard, the joint angles, and also the velocity, then extract the 7 features from each segment. And it is similar for the processing test data. And after training and evaluate, we can see that the F1 score here is now increased to 22%. So the F1 score improved from 16% to 22% after we adding more features suggested by ChatGPT. And the final part is how to generate the submission file. So here I list on the submission ID we need to prediction. We need to predict. And here you can define the path for your CSV file. And you need to give us the labels, the activity prediction of each second in the data. So for example, your submission file will have these 3 columns: the subject ID, the timestamp corresponding to each second, and the activity ID that your model predict for that second. So that's all for the tutorial. So we are looking forward you to join our challenge. And we also, besides the challenge, we also have the main conference here. So in this year, the conference will be held in Kitakyushu and Nakatu Oita in Japan. The title and abstract deadline is today, but we will extend it. So if you have interested in, you can rejoin with us.